In this video, we are going to study about line codes. Is Sridevi, Professor, Department of Electronics and Communication Engineering. On completion of this module, the students will be able to understand the properties of line codes. In analog waveforms, the waveforms are converted to digital signals by pulse code modulation, delta modulation, adaptive delta modulation, differential pulse code modulation, etc. Such techniques. The analog waveform can be converted to digital signals. This digital can be represented in different forms of waves. These waveforms are commonly known as digital data formats. Their representations are called as line coding. So, elimination of DC energy from the signal power spectrum that enables the transmitter to be AC coupled. So, the self synchronization, here the line codes, digital symbols can be amplitude modulated, some carrier to generate amplitude modulated pulse train. Such a signal can be represented as x of t, which is given as the error synchronization signal. The error detection can be obtained by duo binary to provide means of detecting data error without introducing additional error detecting bits into the, that is redundant bits into the sequence. The bandwidth comparison can be done by the bandwidth utilization, that is it is represented by allowing the reduction in required bandwidth for given data rate. So, the power spectral density of line codes depends upon different line codes. So, the signal can be represented as x of t is equal to summation over n into p of t minus nd, where an is the modulating signal's amplitude. So, the line codes can be represented in different formats: unipolar NRZ and non-unipolar NRZ, polar NRZ, like this. In unipolar NRZ format, the waveform does have the single polarity. Uni means single. So, single polarity is there. The waveform can have plus 5 volts or plus 12 volts when high. So, the waveform is simply represented as on and off. That is, whenever it is on, it will produce plus 5 volts, and whenever it is off, there is absence of signal. So, line codes refers the process of presenting the bits in zeros and ones in the form of voltage or current variations, and it can be noticed as plus 12 volts or plus 5 volts. So, the selection of proper line code can help in so many ways. So, one possibility of error is the clock recovery at the receiver. So, the polar, unipolar, similarly the polar RSR. So, in polar NRSR represents non-return to 0 and RSR represents return to 0. Non-return to 0 means there is no return whenever a signal reaches the TB seconds. Let us consider this signal having the bit time as TB, T for time, B for bit. So, TB stands for bit time. So, whenever the bit time TB by 2 exceeds and it returns to 0, that is called as return to 0. And it is not returning and it is continuing to next level, means it is non-return to 0. So, I have Manchester coding also. I have this Manchester coding as another video. So, in that video I will explain about Manchester coding and this unipolar, bipolar, non-return to 0, return to 0, and all these codes are used for represent digital way of representing waveforms. So, the pseudo trinary or alternate mark inversion is used or represented in binary NRZ. We have one quiz question based upon line codes here. The idea of RZ and the idea of NRZL are combined into the dash scheme. So, the Manchester, I said, it is the combination of RZ and NRZL. It is combined to produce the Manchester scheme. So, this line code is used for representing the digital data of digital data representation of signal. Thank you.